I welcome you all. Good morning, students. I welcome you all to the online education of Municipal Corporation of Greater Mumbai. It's our lovely Brihan Mumbai Mahanagarpalika, and we are here for online education for all over the state. Let me introduce myself. As you all might be knowing me, uh, I am from Worli, it is English Municipal Secondary School. My name is Patan Arifa Khatun, and we are here today for Science and Technology, Part 1, and rest you will be knowing as we all go through the slides. Now, today, here from the Part 1 of our science textbook, we are taking today chapter number 5, that is acids, bases, and salts. That's the name of our lesson. In this chapter, we will be studying Arrhenius theory of acids and bases, concentration of an acid or a base, pH of a solution, pH of an acid or a base, lastly, salts. But all these points might not get covered in our today's lecture. है ना? So, before beginning with the lesson, we will be having a revision or recapitulation of the earlier chapter or the earlier basic things which you have studied in your earlier classes, and then we will move to the main topics of this lesson: acids, bases, and salts. So while revising, I hope and I would like to instruct you, okay, you should have your textbooks with you all. Though you are attending the lecture on mobile, but along with it, you should keep the textbooks with you all. So it is quite helpful for you. So from revision part, the question is just taken from your textbook only. This is the question where your chapter starts. And we all know that whenever the teacher starts any chapter, we are supposed to have some question answer session there, and then we go to the real, or we can say the main topic of the lesson. So here the question is given like, okay, how are the following substances classified into three groups with the help of litmus? Litmus means it is a paper, litmus paper. It is just one strip, a paper strip it is. So which are the substances given? I have written there. It is lemon, tamarind, baking soda, vinegar, orange, milk of magnesia, water, alum. These are the things. And we have to classify these things into different substances, but by using the litmus paper. By using the litmus paper. How will do this then? We just know the names of the given substances, and we are quite familiar with all those things. Lemon we use, tamarind we use for making a dal, to make it sour. Baking soda also daily we use for making bhajias, for making cakes, and for all confectionery items. Vinegar also it is used in our Chinese food, and many other also. Oranges we know. Milk of magnesia, it is nothing a special thing. It's just a substance. Then water and alum. Alum also you might be knowing that it is a lump of like a sugar only, but not, it does not taste like sugar. It is very bitter. And we use that alum for the cleaning of the salt, muddy particles in a water, in the water, whatever we use for drinking water. And if it's look muddy, so at such time alum is used to clean such water. So all the dust particle or all the muddy particles, they settle to the bottom, and we get a clean layer of water by using alum. So these were the things. So I just read it out because I wanted to make you also know that these are the things which we use in our daily household life. Okay, then Just now the examples which I have read, in all the above examples or in the above examples, we have seen that some foodstuffs are sour to taste and some other are bitter or soapy to touch. I will give the example of, we will take two examples. The first one was lemon. If you taste a lemon, you know that it is sour. And if you are supposed to take that baking soda or washing soda also, and sometimes it might happen ke unknowingly suppose you are washing clothes and you use that washing soda with your hand, and unknowingly that you taste your finger anyhow, sometimes it happens. So it tastes very bitter, and it is also soapy when you feel, when you rub both of your finger while using washing soda, huh? Washing soda I'm telling you, not baking soda, washing soda. So when you use water and that soda and you rub your both finger, like your thumb and forefinger, you will feel it is soapy. And if you'll take like alum or that baking soda, common soda or daily use soda, and if you are supposed to taste it with your tongue, so you just put one pinch of that baking soda on your salt. It tastes very bitter. So we have come to know about the taste. Now it is very clear that lemon is sour to taste, and whereas baking soda, washing soda, they are bitter, and some of them are also soapy. When they were studied scientifically, it is found that they contain acidic and basic substances respectively. So when they were studied scientifically, they were tested with an indicator. The indicator is nothing uh, else, no one else than the litmus paper. So litmus paper, that is a very easy method uh, to identify the substances, whether they are acids, whether they are bases, or whether they are salt. So that is the safest and easiest method. We can say scientific also. That is also a scientific method. So when they were studied scientifically, it was found that some of the substances were acidic and some of the substances were basic, respectively. An easy method to identify acids and bases is using a litmus indicator. Just now we have, you are listening it. So now how we'll come to know the particular substance is an acid, and the particular, suppose we are given two samples like the lemon and we are given baking soda, and we are asked baking soda or washing soda, huh? We are asked, okay, tell us whether they are acidic or basic, and we are also having the litmus paper. So how we'll do that? Let us see. First, you just go through what the points, whatever I have written on the screen. I've written initially blue litmus paper and red litmus paper. Blue litmus paper and red litmus paper. That means there are two types of paper. The first one, when the blue litmus paper turns red, then the substance is acidic. Initially, we don't know now okay, which one is acidic and which one is basic. So, what we will do then? We'll taste, we'll check, not test, we'll check the lemon or the juice of lemon with the blue litmus paper also, with the red litmus paper also. And when we'll come to know that the blue litmus turns red, when the blue litmus turns red, then we come to know that the particular substance, the lemon, is acidic. And from that lemon, I will like to tell you very easy method to remember the things or the substances which are sour in taste, which are sour in taste, they are acidic substance. And whenever you check the acidic substance on a blue litmus paper, it will turn red. So turning red is an indication that particular uh, substance is a acid, is an acidic substance. All sour substances, examples lemon, tamarind, vinegar, tomato, they all will be testing or they all will be turning red on the litmus paper, and we can draw inference or we can conclude that those are acidic. Those are acidic substances. That means they are acids. They are acids. Okay. Now the next is red litmus paper. Second one I wrote there. When the red litmus paper turns blue, then the substance is basic or alkaline. What we have to do? Again, we'll take two samples only and we'll take both the samples on that two papers. And if the red litmus turns blue with any one of them, then at such time you will say that the particular substance which has become red, which has become blue on the litmus paper is a basic substance, or base. You can also say it as alkaline. Clear with this? When red litmus turns, if you'll just remember one blue litmus paper, blue turns red, red turns blue, vice versa. So when blue turns red, it is acidic. When red turns blue, it is basic. Acidic substances, example, we have taken the sour substances, the sour um, things like the many fruits are there, oranges, then lemon, tamarind, vinegar, they falls under acidic substances. And about basic substances, baking soda, washing soda, then milk of magnesia, they are basic substances or alkaline substances. Okay. So in this way, we have come to know when we want to classify elements into salts, acids, and bases, the thing which we will use will be blue litmus paper, red litmus paper, and then we can classify them as acids, bases, and salts. So with the help of litmus paper. Now, I'm sure that as soon as you are, as soon uh, as soon you will seeing this image or this screen, immediately you'll come to know that it is from the textbook. Yes, it is from the textbook, page number 58, and an important information. Though it is excluded from the syllabus, but we will be taking this because it will be helpful for us for the further part of this chapter. Here we can see one table, and we shall now learn about the acids and bases. But let us first review what the molecules of compounds are made up of. There are many compounds which we use in our daily life, in our routine life. Any compounds, all they are formed through some type of changes, physical changes, chemical changes, gaseous changes, whatever the things we use in our daily course of our life. So here we will come to know how the compounds are made up of, and so I have taken this part to let you know. But here I have not written any of the answer there. Only the first one is given. That is the first column is name of the compound, that is hydrochloric acid. Molecular formula. Every compound has molecular formula. Molecular formula of hydrochloric acid is HCl. Third column is basic radical, H plus. Acidic radical, Cl minus. Then the compound will be known as acid. So chalo, let us try to define from this table what is an acid. What is an acid? Now the second one. Second one. I will tell you. If you're carrying your textbooks, you could write here HNO3. It is name of the compound is nitric acid. The basic radical is H plus there, and NO3 is the acidic radical there. Type of the compound is again acid. So though two I have shown you. The first one, let us define them. Here you could see in the second column, that is molecular formula. I will be showing you in the next slide. Molecular formula. Okay, there some of the compounds, the initial 2, 3, 4 compounds, HCl, HNO3, HBr, H2SO4, and the next one also H3BO3. They are having the basic radical H plus. Yes, they are having the basic radical H plus and the acidic radical Cl, NO3, Br, SO4, BO3. The main thing for an acid is it should have a basic radical H plus only. And at such time you will say immediately, you can say that the particular compound is an acid when it have a basic radical H plus. Then again moving downwards, that is the sixth one, NaOH. It is sodium hydroxide. It is sodium hydroxide. You could see here the in this compound or some compounds we can see here, they have OH minus as the acidic radical in their base, um, in their molecule. OH minus, they are having OH, NaOH. We can see here some compounds like the NaOH, the KOH, CaOH twice, NH4OH, NaOH, sodium hydroxide, KOH, potassium hydroxide, CaOH twice, calcium hydroxide, and NH4OH, ammonium hydroxide. OH, 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 OH. They are having OH as their acidic radical. So such compounds are called as bases. Such compounds are called as bases. Whereas again, when you will move down, 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 and 5 more compounds are given there. The first one is NaCl, that is the sodium chloride, CaNO3 twice, calcium nitrate, K2SO4, potassium sulfate, CaCl2, calcium chloride, and last one is ammonium sulfate. So these ionic compounds which have a basic radical other than H and acidic radical other than OH, they are called as salt. Observe carefully. NaCl, we'll take one only, NaCl. NaCl is sodium chloride. What is the basic radical of NaCl? Na. What is the acidic radical of NaCl? Cl. Now, in the basic radical side, it does not have H plus, and in the acidic radical, it does not have OH radical. It does not have OH radical. So such compounds, they are called as salts. They don't have H plus also. They don't have OH minus also. So they are called as salts. So some compounds are seen to have H plus as basic radical in their molecules, like HCl may H plus. So these are all acids. Whereas some compounds are seen to have OH minus, like NaOH, acidic radical side. Basic means initial one, starting one. So some compounds they were having as basic radical H plus. So firmly they are always acids. But some compounds they are having OH negative as the acidic radical in their molecule. So all these are bases. But there are also some compounds which have basic radical other than H and acidic radical other than OH. Such compounds are called as salts. So it will be clear it will be clear that there are three types of ionic compounds, and these are acids, bases, and salts. Clear now? Three types of compounds I have shown you. Acids, which have basic radical H plus and acidic radical Cl minus. Acid. Basic ones, which have uh, acidic radical OH, which have acidic radical OH, they are bases. And the third type, that is the salts, they have acidic radical other than H plus, basic radical other than OH. They are called as salt. So these are the three ionic compounds: acids, bases, and salts. Here you come. See here. Again, I have written just taken out the three examples for one acid, one base, and one salt. So same columns I have made there. Name of the compound, molecular formula, basic radical, acidic radical, type of compound. The first one is hydrochloric acid. Molecular formula is HCl. Basic radical, look into the molecular formula, H plus. Acidic radical, Cl minus. So definition forms for a acid. When the compound have basic radical H plus and acidic radical Cl minus, then it is acid. Finish. Sodium hydroxide compound. Molecular formula, sodium is Na. OH is hydroxide. NaOH, sodium hydroxide. The basic radical is other than H plus, Na plus. But the acidic radical is OH minus. OH minus. Acidic, more important is acidic radical. When the compound contains OH minus ion as the acidic radical, then it is a base. Definition. Last, third one. The third type of ionic compound, that is the salt, sodium chloride. Molecular formula is NaCl. What is the basic radical in sodium chloride? Na plus. Acidic radical Cl minus. So when the compound have basic radical other than H plus ion and acidic radical other than OH minus ion, then it will be known as a salt. Here we come, and here we can properly or confidently say okay, there are three types of ionic compounds. They are the acid, base, and salt. Acids, bases, and salts. Okay, it was just a single acid, that is why it is written here acid, base, and salt. So generally we will say that if I answer, if I question you, okay, what are the types of compound, ionic compound? So you must answer there are three types of ionic compound: acids, bases, and salts. I hope you are getting it. So let's have a recapitulation for the ionic compounds only then. Ionic compounds recapitulation. That means we are revising it. The molecule of an ionic compound has two constituents, namely cation, that is a positive ion, or basic radical. Namely the cation, that is a positive ion, basic radical, and the anion, that is negative ion or acidic radical. Yes, ionic compound. We'll take the example of HCl. HCl is ionic compound. It has two constituents. Cation. Cation means positive ion, that is the H plus ion, or you can also say it as basic radical. In the table we have seen basic radical, acidic radical type of compound. So the ionic compound, it has two constituents, mainly the cation, that is the positive ion or the basic radical, and the anion, the other or the remaining part, that is the negative ion or the acidic radical, Cl minus, OH minus, and NO3 minus. So that is the anion. Negatively charged anion, positively charged cation. So there is a force of attraction between these due to the opposite charges. They have opposite charges, no? H plus Cl minus, Na plus Cl minus, Na plus OH minus. So they opposite charge. One is positive, one is negative. So due to this opposite charge, there is a force of attraction between both of them, and that one is called as then the ionic bond. That particular thing is called the ionic bond, which is made from the cation and the anion. Okay, I'm on again. We are on the same page for this part only. These two, the figure is taken from your textbook only, because if you'll study through this, you could find easy when you go to the textbook. So it is given on page number 59, 5.1. Okay, what is the title given for the figure 5.1? Formation of the compound NaCl electronic configuration. Now, you must not ask me ki what is the electronic configuration means. Electronic configuration. We know that the atom, it has nucleus and it has shells and or the orbits, and in that orbit all the electrons, they revolve. They are distributed in the shells. They are distributed in the shells, and that is nothing but the electronic configuration. The first shell have the minimum is one electron, and that's on then 2 3 anyhow, depending upon the arrangement. So that this is the first shell has one electron, sometimes it has two electrons. So this is called as the electronic configuration. So we have learned that there is a natural tendency of any body to change from an electrical charge state into an electrical neutral state. हमारी body की tendency होती है, our body has a tendency कि it changes an electric charge into electrically neutral state. So why? Then is an electrically charged ion form on an electrically balanced, that is a neutral atom. The explanation lies in this electronic configuration only. Let us see once again how the sodium and chlorine atom forms the Na plus and Cl minus, and as a result how the salt NaCl is formed. Salt NaCl, your daily household salt with which our food tastes, your daily edible salt, NaCl. The molecular formula of that salt is NaCl, and the name of the compound is sodium chloride. So figure 5.1 shows how this takes place, how the electronic configuration, how the sharing and donation of electron takes place. At the very beginning of this figure, or the on the top of this slide, you could see the electronic configuration of sodium is 281. That means the first shell, it has 2 electrons. The second shell, it has 8 electrons. The third shell, it has 1 electron. It is being shown there, just one dot. What is happening now? Sharing of electron is done now. One electron is leaving sodium. One electron is leaving sodium. After leaving one electron from the sodium shell, from the sodium element, one electron is gone. It has shared one electron, donated one electron. Now sodium is left with only two shells. That is, one shell it has 2 electrons. The second shell it has eight electrons. This is done with sodium. Now the chlorine also. Chlorine, it is having the electronic configuration is 2 8 and 7. 2 8 and 7. The first cell 2 electrons. Second shell 8 electron. Third shell 7 electrons. But if we'll match sodium and chlorine, so we get to know the second shell, it has 8 electrons for sodium also, and the chlorine also. And the first shell 2 electron, chlorine also 2 electron. So 2 8 2 8, similar. But the 1 and the 7, now they have to get merged. That 7 now it has to become 8. So that's why sodium is sharing the electron. That's why sodium is sharing the electron. Now that sodium it shared the electron to chlorine. And here chlorine you could see when it was having 7 electrons, 2, 2, 2, 6 and 7. But after receiving 1 electron from sodium, now it has also become 288. First shell 2 dots. Second shell 2, 4, 6, 8, 8 dots, electrons. Third shell 2, 4, 6, 8. Right? 288. Now it is a complete octet. Octet means what? It is having 8 electron in its outermost orbit. In its outermost orbit. Okay. So now it has become complete octet. In the third figure, the figure is one only, but in the third step, it is clearly shown how sodium is donating electron to chlorine, and after sharing the electron and after accepting the electron or after receiving the electron from chlorine, the NaCl with an ionic bond or the compound NaCl is formed. The compound NaCl is formed, where sodium it is having 2 shell, that is 2A, and the chlorine it is having the 3 shells, 288. That means the last orbit of sodium is complete octet, and also the last orbit of chlorine is a complete octet. And in this way, a stable compound, that is sodium chloride, is formed. Okay. This is the thing which I told you just only. So the outermost shell of the sodium and chlorine is not a complete octet. It was 281, it was 287. However, outermost shell in both the Na plus, when the sharing and receiving of electron is been done, and NaCl minus ion is a complete octet. When it becomes a complete octet, when sodium is 28, when chlorine is 288. So an electronic configuration with a complete octet indicate a stable state. Further, an ionic bond is formed between the oppositely charged Na plus and Cl minus ion, and therefore an ionic compound NaCl of very high stability is formed. In this way, the ionic compound sodium chloride is formed. Again, I have used some more figures to get your concept clear. See here, sodium ion Na plus, complete octet. Now it has donated the electron and it has got the charge positive 28. Chlorine, red one, if after receiving the electron from sodium, it octet become complete, and we can clearly see the blue dot which is in the chlorine shell. We can clearly say it is received from sodium. Another picture is also the same. Uh, Initially 281, 281, and then chlorine, when it donate the electron, chlorine becomes 288. I hope you understood it. Now the next topic for today is the dissociation of ionic compound. The dissociation of ionic compound. So on dissolving in water and ionic compound. Always remember ionic compound, the very common example, the very easiest example, sodium chloride or salt, which is easily available at every one house. So on dissolving in water, an ionic compound forms an aqueous solution. In the solid state, the oppositely charged ions in the ionic compound are sitting side by side. I'll show you, will make you clear with the figure. Just read out. They are sitting side by side. When an ionic compound begins to dissolve in water, the water molecule push themselves in between the ions and of the compound and separate them from each other. That is to say, an ionic compound dissociates while forming an aqueous solution. Let us try to understand with the given figure. Yes, is it in your textbook? Yes. So what I said, on dissolving in water, you are putting some salt in water. So salt is an ionic compound. So when salt dissolves in water or when the ionic compound dissolves in water, an aqueous solution is formed. So in the solid state, when the salt is in solid state, so the oppositely charged ions, the Na plus and the Cl minus, they are very close to each other. I will zoom and show you. Here, they are very close to each other. The green ones and the brown ones, they are close to each other. They are close to each other. They are sitting side by side. But when the ionic compound begins to dissolve and when it is forming the aqueous solution, the right side one, they, the water molecules comes in between the Na plus and Cl minus, and the water molecules push the ions of the compound. And in this way, the Na plus cations and the Cl minus anions, they get separated from each other. In other words, we could say K anionic compound dissociates while forming an aqueous solution. So when an aqueous solution is formed, the ionic compound dissociates. That was the thing which I wanted to show you. So each of the dissociated ion in the aqueous solution is surrounded by water molecule. Yes, we can clearly see here on the right side, the green one and the brown one. They all are surrounded by water molecules only now. And in the left figure, the green ones and the brown ones, they were together. And but after that, what happened? The water molecules, they started pushing themselves. They started pushing the Na plus cation, Cl minus anion. And due to that, what happened? The Cl minus anion and the Na plus cations, they got surrounded by water molecules. This state is indicated by writing AQ, meaning aqueous, AQ, Na plus aqueous, Cl minus aqueous. And they are written on the right side of the symbol of the ion, Na plus in bracket aqueous. So in this way, the dissociation of salt in takes place, forming an aqueous solution. है ना? Easy to understand. And the chemical reaction can be written as like this: NaCl bracket में solid, because initially the salt was solid when we were dropping it from the bowl. When it was dropping from the bowl, so it was a solid NaCl. Then the reaction that took place, that was dissociation, and we have added the NaCl in water, and what happened? Na plus aqueous is formed and Cl minus aqueous solution is formed. So I hope you, after this, you could have understood this, and these were only the topics that which we could have taken today, because we have to manage between the time, है ना? So after all that, we'll come to the evaluation part, and I will only answer because you all are muted. You just pay attention to the evaluation part. I will go on reading and answer. The first one is, I have taken some easy questions which we have gone through. Basically, we have gone with the revision part only today, and two topics, that one topic we have completed, that is ionic compounds, recapitulation, and dissociation of ionic compound is almost completed only. So the questions or the fill-ups are based on that portion. So the fill in the blanks, the first one is blue litmus turns dash in an acidic solution. Blue litmus turns red in an aqueous acidic solution. Second one, red litmus turns blue on a dash solution. That is a basic solution. Third fill up, the compounds which have H plus as the basic radical in their molecule is an acid. Basic radical H plus, acidic radical Cl minus. Not always Cl minus. Sometimes it might be SO4 minus also, NO3 minus also. है ना? Then the next question is, sir, in one line. And the first question is two constituents of ionic compounds. Very easy. The two constituents of ionic compounds are the positively charged or the positive ions or the cations. Also, they are called as the basic radical, or the other one, negative ion or the anion, or you can also call them as the acidic radical. What is the salt then? The compound which has acidic radical other than H plus and basic radical other than OH. Sorry, the what is the salt? The compounds which has basic radical other than H plus and acidic radical other than OH. Such compounds are called or known as salts. And the last one, three types of ionic compounds. Very easy. I have shown you through the table three types of ionic compounds. So that were the salts. Sorry, the first one is the acids. The three types of ionic compounds are the acids, bases, and salts. So with all this, we we are we are moving towards the end of the lecture, and I hope you all might have understood it and as well as enjoyed also. So thank you all for joining the lecture and happy learning, and follow the instructions for your COVID safety, that is use a mask, stay home, keep distance, and wash your hands at regular interval. Take care of yourself and your family. Okay. So